Hello, my name is Roy Simpson. I'm a professor of mathematics at Cusumnes River College in Sacramento, California. In this video on in differential calculus, or first year calculus, we're going to go ahead and prove a very common theorem that if you have two functions that are equal, except possibly at a point A, okay, then the limit as x approaches A for each of those functions must be equivalent as long as those limits exist. Visually, what this is actually saying is the following. You have some function f, which I'll go ahead and draw in here like this. Notice I put a little hole at A. It doesn't need to have a hole at A, but I'm just putting one in. And then you have a function g, which is exactly, or looks almost like this function, everywhere for the same values of x, and this is not as obvious as I'm trying to make it out to be, but these two functions are the same, and maybe g, so g is in red, notice they're the same function, g might have a value down here at a, but the fact is that the limit as x approaches a of both these functions must be the same, is what this theorem is stating. Visually, you can see that that is the case, but that is not a proof, just seeing something. So let's go ahead and do a proof, and in a proof, you often need to, or it's often a good idea, to start at the beginning the if statement. So I'll highlight the if statement. You may assume everything in the if statement, and then through logical arguments, arrive at the then statement. So we want to arrive at what I'm highlighting in blue. Now this little extra language here, provided these limits exist, that's going to be part of our if statement as well. So we are assuming that the limits exist, and we're assuming that f of x equals g of x for all x not equal to a. So let me go ahead and state that as the first part of my theorem, or the proof of this theorem. So I'm going to say, suppose that f of x is equal to g of x for all x that's not equal to a, so that's the first highlighted part up here, and that the limit as x approaches a of f of x is some value L, and the limit as x approaches a of g of x is some value M. And when I write those in there, that is insinuating that these are actual finite numbers, they exist. Okay, so I'm going to, you can also, by the way, put that into your proof. You could say, kind of in language so that the world knows, you could say that is, both limits exist and are finite. Great. Now, we happen to know from the precise definition of a limit that if these limits exist, then we can rewrite them in the epsilon delta format. So let's do that. I'm only going to do it for f here. So I'll write therefore, for all epsilon greater than 0, there exists a delta that's also positive, such that as long as the distance between x and a is positive, or not positive, but the distance in x between x and a is non-zero but yet less than delta, so there x cannot be a, that will imply that the distance between f of x and L is less than epsilon. So I'm actually basing this argument on the fact that we say that this limit here exists and is equal to L. Okay, well, what does that mean? Well, that means that since f and g are the same for all x not equal to a, that the distance between f of x and L is the same thing as saying the distance between g of x and L, because again, f and g are the same as long as x is not equal to a, and x cannot be equal to a because of this statement right here. So we know x is not equal to a already, so therefore f and g must be the same function. And this is going to be less than epsilon. That is, for all epsilon greater than 0, in fact, the same epsilon that we had listed above, there exists a delta, and exactly the same delta that we would find in the previous case, such that the distance between x and a being less than delta, where x is not equal to a, will imply that the distance between g and L is less than epsilon, which implies that the limit as x goes to a of g of x is also equal to L, which basically means that our original claim, suppose that f and g are the same for all x that are not 0, and that the limit as x approaches a of f of x is some finite number L, and that the limit as x approaches a of g of x is some finite number M, we now know that through our argument, L and M must be the same numbers. So that implies L must equal M. In other words, that these limits are the same. And that is actually the entire point of the proof. Remember, we wanted to basically claim everything in yellow here, that f and g were the same for all x not equal to a, provided these limits exist. And when we wanted to prove that the limits were the same in blue there, and that is actually our last sentence down here. So this is the end of the proof, QED.